this. So we'll start with 131. If you want to follow along on your computer, your desktop, or your laptop, you can go to Kaiser Live. You all know how to do that. The thing of it is if you go there and try to do problems, homework problems, while I'm doing this, the numbers always change. You see, you got 53%, 2302. If I come back to this problem right now, just if I leave it and come back, see now it's 17%. See, the numbers change. So whenever you open a problem, you get different numbers. So when you ask me for help, I'll try to use your numbers. And the way you do that is, by the way, get more help. If you hit Ask My Instructor, that will send me an email. And it'll have this problem. Just like it sits here, it'll come to my email address. And as soon as I can answer it for you, I will. I'll either give you a hint or I'll give you a video, which reminds me, I'll show you that now. If you look in your Blackboard course, you see under week 1, it has all these videos. They're YouTube videos. They're my property. So this is problem 2.1.7. This is chapter 2, section 1, problem 7. It's a homework problem. Somebody asked me to do a video. So if you just hit that link, it's me doing the problem. And you can stop it and play it. The problem is numbers that are up here are the ones that when I opened it, your numbers may be slightly different, but the process will be the same. Okay? You all understand that? All right. So I have them for unit 1, for test 1, and then in week number 2, I have them for test number 2, and then in week number 3, I have them for test number 3, and this is the one that's the most populated. Because stuff gets a little more involved by the time we get to the 3rd unit, the last 3 homework. There's more involved. There's more going on. We have to develop tools here in the first couple of units. All right, but that's all there for you to use. Okay. So we're going to start with 31. Some of this might seem out of place. This is actually a review of the percentages. So if I'm going to solve this, they want 17% of 2286. Now we can't use percentages to calculate. We have to turn that into a decimal. So it's 0.17 times 2286. And so it says the exact value. So they don't want me to round it. So I got to put that number in there, 388.62. No round off. And then could this result be the actual number? Why or why not? Well, we just talked about that at the very beginning, remember? We can't have part of a person. You either say 388 or 389 when you report it, when you actually report it. So the answer is no. So it's either A or B. See, the result has to be a whole number. That's the notion. Because it's discrete. You can't count. If you say 17%, the 17 is probably a round off. Okay? So you can give an exact answer like they asked us. And then the trick is, can you use that exact number? No. But I think you could round it either way. You'd be okay to round it to 388 or 389. Most people would round it up 389. What could be the actual number of adults who said they play basketball? Okay, so I just said we could do it either way. Let's see if they'll take 388. See? They'll take it either way. Obviously, if I did 389, they would have taken that also. All right? Among 2,286 respondents, 373 said they only play hockey. What percentage? So for a percentage, I need a fraction. So the number of successes is the hockey players, 373. divided by 2286. So to the nearest two decimal places. They see the answer is as a percent. So I have the answer up here as a decimal. So to change it to a percent, I got to move it over 2. So it's 16.32. That's the second decimal place in a percent. Everybody see that? So it's 16.32. Okay, let's say I was careless. Let's say I put 16.31. This time they don't like that. They want me to round it correctly. Now the reason I'm showing you some of this is because when you're doing homework, unless it's a fill in the blank for a name, you get 3 chances. So if you screw up like I just did, you got 2 more chances to get it right. Like if you put a capital X instead of a lowercase x, or you put a comma instead of a decimal point, just go back and make sure that or if you put an extra 0 or something, you did round it off incorrectly, you got a chance to redo it. This is only for homework, not for test. For test, I'll be the one to go back and see if you made a mistake like that. Because I don't care about those kind of things. If you round off incorrectly, I'm going to give you credit. But I can see that. I can see what you did, and I can tell you that you didn't round it off correctly. You didn't follow their directions correctly. I'm not going to hold it against you. You won't get a 0 because they'll give you a 0. I'll give you 4 out of 5 or 3 out of 4. I'll give you benefit of the doubt. Okay, so nothing will be overlooked as far as the test. I always go back. I usually find everybody a couple of 3 points, 4 points extra. You remember that?
Yes, I do.
Okay. So nothing will be overlooked. But you got to follow their directions as best you can, okay? All right. And the editorial criticized a chart caption that described dental floss as one that reduces the chance of people on chance of plaque on teeth by over 300%. So what's wrong with that? Anybody realize what's wrong with that? I could increase something by 300%. Is it possible to decrease something by 300%? What's the most you could possibly decrease something? If you decreased all of it, it would be 100%. So 300% is out of the question. It's not possible to reduce by more than 100%. See, a reduction of 100% would eliminate all the plaque. What are you reducing after that? Teeth. So it's, people throw around numbers. You just have to be careful. They're just pointing it out to us. Yep. Which of the following is not a voluntary response sample? So I talked about random samples. A voluntary response is like he said he was going to stand at the door and get the people when they came in. That's voluntary. Because a lot of people will tell you, bug off. You go to Edison Mall and you want to get somebody to sign a petition, which one they like better, Pepsi or Coke. You think everybody's going to come running over and sign your petition? Most people got kids, they're busy, they're carrying stuff, they don't want to be bothered, go away. So the ones you get are the ones that will say, okay. Or if you're online on the internet and you see a question that you can answer, multiple choice, will you answer this question? That's voluntary, right? Or if you get a postcard in the mail, hey, will you call this number and answer a few questions? That's totally voluntary. There's no randomness about it, so it's not scientific in the sense that everybody that had a chance was equally likely to be chosen. So it's not random. And so voluntary responses are usually problematic. You usually can't use them to make sound inferential judgments. So which of the following is not a voluntary response? I'll start with D. A local dentist asks her patients to fill out questionnaires and mail them back. That's voluntary. A radio station's asked for call-in responses. Voluntary. A survey's taken at the mall. That's one I just... So the first one, quiz scores from a college-level statistics class are analyzed. Well, that's not voluntary. If I got, say, pop quiz, it ain't voluntary. You get the idea? All right. Number 3. Which does it mean for the findings of a statistical analysis of data to be statistically significant? I'll give you a couple of seconds. it harkens back to what I said about confidence intervals. You can imagine the confidence intervals, you want to make them as big as you possibly can, depending on what you're looking at. Like, I'll give you a hint here. When you're dealing with medicines, you want the confidence interval to be as large as 99%, which means the tails will only hold 1% and it's split up 0.5% on each tail. Which one? Nope. Think what I was talking about. See, this is an example of they call it empirical rule. It's a normal curve, normal probability distribution. It's a normal curve. You can see that the way to read that is, if you look at on the left, there's x bar minus 3s. S is the sample standard deviation. So I'll write that up here. Sample standard deviation. See, that's the spread. That's how we measure spread. SD. And just so you know, the population standard deviation is sigma. That's a lowercase Greek s. So s is the statistic that estimates sigma. But if you have x bar and you subtract 3 standard deviations to the left, and then you add 3 standard deviations to the right, you create a 99.7% confidence interval. So the chances of ending up in the tails is very remote. It's very small. That's it. The likelihood of getting the results is very small when you end up in the tail. Even with a 95% confidence interval, you have 5% split between 2 tails. That's 2.5%. That's a small. 5% is 1 chance of 20. That's pretty remote. See, 99%, there's 1% in the tails. That's 1 chance in 100. That's very, 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 very small chance. But if it occurs, that's when you have to make a decision about the claim that got you there in the first place. See? All right. So remember, whenever we end up in the tails, it's significant. It's either significant low or significant high, but it is significant. All right. Let's go to the next section. Any questions so far? We're just setting ourselves up for how to use the stuff, how to talk about it, the lingo. I'll try to remember as many things as I can as we go. So now it's going to be the statistic or parameter. So for statistic, you see the word sample, random. For parameter, you think of all, the entirety of a population, because populations mean everything. So in a study of all 2,647 professors at a college, it was found that 25% own a television. So the underlying one is the one we're looking at. That's the statistic, 25%. That's a proportion, right? 1/4, 25%. So is a sample? Is it a statistic or a parameter? What gives it away? There's one word gives it away. Oh. So it's a population, therefore it's a parameter. So parameter, because it describes something about the population. The population is all the professors at that university. It's not always, doesn't always work, not 100%, but that's one of the keys to give it away. Next one is same thing. Oh, qualitative or quantitative. Quantitative means measuring or counting. Qualitative is like what kind? Blue eyes, green eyes, brown eyes. That's quality. You can't count or measure that. You can just, male, female. It's a quality. It's qualitative data, right? Because you don't measure or count gender. You just state it. It's a quality. So the blood groups of A, B, and O, are those qualitative or quantitative? See, those are just names. Anytime you have names, it's usually qualitative. So those are qualitative. See, they don't measure or count anything. They just name the types of bloods. And we're going to be dealing with almost exclusively quantitative data. Almost exclusively. Okay, now discrete and continuous. the two different ways to measure. So discrete, think of the word count. Continuous, think of the word measure. Like you're actually measuring time, height, weight. Money would be discrete because you're counting money. You count money, so it's discrete. Right? So the maximum capacities of various stadiums. So what's the capacity mean? That means attendance, right? How do you take attendance? You count it or measure it? You count it, so it's discrete. Because it takes, the buzzwords they use here, it takes on specific values. The alternative would be it takes on a value in an interval. Because technically, if you have a continuous data, like the time it takes to cook an egg, it's on an interval. It doesn't have to be a particular number of seconds. And the thing of it is if you say it takes five minutes, somebody else might say it takes 4 minutes and 59 seconds. And somebody else will come along and they can say, no, it's between those two. So you can always find something between two measures that are continuous. Depends on how fine you want to measure. But counting, if you got 2,468 paid attendance and somebody says, no, it's 2,649, there's nothing between them. They take on specific values, discrete values. Okay, see the difference? Number 10. A sample of 518 doctors showed that 10% were optimistic. You see, what's the word that gives it away? Sample. So it has to be a statistic. So it's a sample. So it's a statistic sample. See, they have the two words statistic and parameter, and then they have population and sample. So there's 4 possibilities, and they try to confuse you. But as long as you know it's a sample, then it has to be a statistic. So it's B. All right? You can sort that out. 11. A sample. It's a statistic, right? As soon as I see that word, I laugh, but that's what it means. Let's see if we can find one that isn't. The numbers of computers in a network at different times. Discrete or continuous. I see we're jumping around. We're doing the number. Count. Very good. It's discrete because it takes on specific values. Am I going too fast or anybody getting confused? The area and square feet of different apartments in a town. Do you count area or measure area? Measure. See, if you use those two words, it's a dead giveaway. You can figure out which one's which. So it's continuous because it takes on values in an interval. What does that mean? How accurate you want to be? You know, it could be depending on who's measuring. You could get several different answers. I guarantee you, that's the way it goes. 17. The exact mass in grams of food eaten by a person each day. So, do you count grams or measure grams? You measure grams. That's right. So it's continuous. All right? How do you measure it? With a scale. And depending on the accuracy of your scale, you can have scales that have little weights. You can have digital scales that go to 3 digits. You can have, how many of you taken chemistry classes? You ever seen those ones that have a hood over them? You put it in the balance so there's no wind blowing, and that measures to the nearest thousandth of a gram. Well, you can imagine there's probably ones that measure even more accurate than that if you needed it. So it all depends on how accurate you want to be. Of course, some people would say there's always a limit to the accuracy. We're not here to discuss that. The number, see, the number of stars you measure stars or count stars? You count them. So It's discrete. I think we're driving it home. Maybe one more here. No, that's it. Okay, so they talk about all these other levels of measurement, nominal and all that. We don't care. I don't care about that. It's not that important. I just want you to remember discrete continuous, quantitative qualitative, and parameter statistics. Those are the most important things we want to discuss. So we're actually moving on to the last section. The first couple lessons are actually pretty quick here. I know it says on the 5 to 8 or 5 to 9, but we're usually done by between 7 and 7:30 usually. Sometimes earlier, but hope that's okay. All right, collecting sample data. Okay, so this might be a little different here. Let's see. We start with 6. And I think they're going to talk about, the difference between an observational study and an experiment. In an observational study, all you're doing is measuring or counting to gain data so you can describe what you saw. In an experiment, you're actually going in, you're delivering something that can alter the outcome of, at least, if not all of the people, at least part of it. You split them up into, control group and experimental group. So you're actually giving something to the people or animals or plants that are involved in the experiment. So research is conducted to determine if there's a relation between brain cancer and the use of cell phones. Observation. Because you're just taking measurements of different things concerning people and how much time they were on the phone. So it's completely observational. Make sense? I hope. Number 7. A study of an association between which ear is used for cell phones calls and whether the subject is left-handed or right-handed began with a survey emailed to 5,000 people belonging to an optology online group, and 717 surveys were returned. Optology relates to the ear and hearing, in case you weren't aware of that. What percentage of the 5,000 surveys were returned? So I need a fraction. We call that went right out of my head. Proportion. It'll come to me. So we need the fraction. We need to take the number of successes, those returned, divided by how many were sent, right? And so to get the fraction, it says round to the nearest whole number. So as a percent, that's 14%. It's 14.34, but it says round to the nearest whole number. So we're going to say 14. That's about 1 out of 7, right? Because 7 times 14 is 98. Does that appear to be low or high? Low. So it appears to be low. Actually, for survey responses, 30 to 35 is considered what you normally get. So 14 would be rather low. In general, what's the problem with a low response rate? So that's actually the first one. Because remember now, this is a convenience. So the only people that are going to reply are the ones that are interested in replying, and they may have a bias. That's the reason they replied. So it's A. It creates a serious potential for getting a biased sample, because those are the people that are interested. Some of the other stuff is kind of misleading. We could look up what blinding is and whatnot. By the way, if you're not sure, you can open the textbook right here, and you can have it open. to the section that the section that you're working on. So this will be 1.3. So there it is, 1.3. And if you want to know what blinding is, you'd have to do a little bit of work to find it. There it is, blinding. Is used when the subject doesn't know whether he is receiving a treatment or a placebo. So that's not the case. This was an experiment, so that's they're taking a word. If you want to know, then you can find it by using the textbook. You can leave it open as you're going. See, you can leave it open. What other ones in there that might confounding? What's confounding? I think if they use these words, they must have a reason for it. I'm going to leave this open because we're going to use some of these notions. So there's observational study. Let's see, confounding. There, confounding occurs when we see some effect but can't identify the specific factor that caused it. So they're taking words from this section and misapplying them. So if you're unsure and you want to know where they got those, you can find them in here. It just takes a few seconds to find them, and then you can know that they're just trying to pull your leg. Okay, so number 9. Okay, so now we're going to talk about the different types of sampling. We already talked about convenience sampling. We already talked about random sampling. We're going to add systematic, cluster, and stratified. So maybe the easiest thing for me to do is to show you an example of those. So you see it ahead of time. So let's say I wanted to sample from a school that's had 500 students. And there were 25 homerooms. You guys remember homerooms, right? Mm-hmm. And so there were 20 per homeroom. That makes 500. So if I were going to do a systematic, I would give all the 500 students a number from 1 to 500, and then I would say, I want to get 50 of them, right? Systematic. I would say take every 10th student with number 4 first. So it'd be 4, 14, 24, 34. And I would have a systematic random sample of 50 students. Make sense? All right. A stratified sampling, I could give you 2 examples of a stratified. I could say split into 4 classes. What 4 classes? Freshman, sophomore, junior, senior. Then take a random sample of 15 students from each class. That'd give me 60, but I would get to 50. Okay, so I'd have to split them up into 4 classes, give them all numbers, and then pick 15 at random from each of the classes. A cluster, I would randomly select 3 homerooms and sample all students. So that would give me 60 that way, right? I'd take 3 out of the 25 homerooms and I'd have 60 people. I'd get them all. So see, the difference between a stratified and a cluster is here we split them up into groups, but we randomly sample from each group. Here, we randomly select the groups and sample everybody in the groups we pick. So for this example, you'd have to decide which one's the most effective, cost effective for time manpower, it would be the cluster. Because you'd only have to identify 3 rooms. You see, if you were to identify every 10th student, they'd be all over the place in all 25 rooms. You'd have to go with all 25 rooms. Same with the stratified. You could split up into two classes, say gender, girls and boys, and go find random sample of 25 from each category. It all depends on how you want your sample to display as much across the spectrum of the various things you're trying to identify. If it's the age, you want to do the 4 classes. If it's the gender, then you want boys and girls, you want both of them, then you want to do that as your 2 strata. But if all you care about is 50 students, that's the easiest one for this one. And then a convenience would just be to find 50 students walking through the hallway and just first 50 you get. All right, but that's not going to be random. That's a convenience, and it's not scientific. These are all scientifically based. The simple random the truly random would be to take all of the 500 students, give them all a number, and randomly pick 50 numbers. That's a simple random sample, because those 50 are just as equally likely to be chosen as any other sample of 50. That's what that simple random means. Okay. Of course, they don't say simple random here, but we will get to that. So a researcher selects every 574th Social Security number. Is it obvious? Systematic. So there'll be some repeats here, but you'll get the idea. 11. In a poll conducted by a certain research center, 1,081 adults were called after their telephone numbers were randomly generated, and 24% were able to correctly identify the present. It's given away. It's random. Yeah, it's random. Because they were selected randomly, so it's a random sample. There's no trickery there. Number 12. A woman is selected by a marketing company to participate in a paid focus group. The company told the woman that she was selected because everyone in 4 randomly selected towns was being selected. The towns were randomly selected, but you see, everybody in the town was everybody in the 4 randomly selected towns. So it's however many towns they have. A lot of times businesses do that. They'll have 50 outlets, 50 restaurants in their chain, and they want to do a sample. They'll just randomly select 5 out of the 50 restaurants, and then they'll just go there and sample everybody in that restaurant for their results. So yeah, this one would be what we say, cluster, right? Number 13. To determine customer opinion on their safety features, Daimler Chrysler randomly selects 100 service centers during a certain week and surveys all the customers. They randomly selected the service centers, and then they got everybody in each service center. It's the same thing. It's a cluster again. Yeah. Once you see that all, when they randomly select the places, but they get everybody in each of the places selected, it's going to be a cluster. I'll tell you when a cluster is really good is for agricultural purposes. Farmer has a huge cornfield, and he doesn't want to be people traipsing all over the cornfield and selecting two ears here, and they'll ruin it. So they make a grid map, and they'll say, "Here's 1,000 grids. Okay, let's select 10 grids randomly, and we'll go in there very carefully in the one grid. Let's say it's a 5x5 or a 6x6 plot, and we'll select all the corn that's in that grid. So there's these 10 spots strategically randomly picked, and that's what they use as their sample. And it's a better way to do it because you're not ruining the whole field by tromping through it, grabbing all your gear. And A large company wants to administer a satisfaction survey to its current customers. Using their computer database, the company randomly selects 50 customers and asks them about their satisfaction. Random, yeah. Straight up, random. 16. Okay, to estimate the percentage of defects in a recent manufacturing batch, quality control manager of General Foods selects every 19th soup can coming off the assembly line. This is typically where a systematic is used when you have a line of something's coming by, you're selecting every systematically, so I gave it away as systematic. Okay, that was 16. I'll just keep going here. A woman experienced a tax audit. The tax department claimed that the woman was audited because everyone in 4 randomly selected districts was being audited. Sound familiar? No? You guys are hiding out. See, everybody in 4 districts, the districts were randomly selected, so it's a cluster. A market researcher has randomly selected 4 neighborhoods. Once again, it's a cluster. They keep their. See, if I open this up again, it might change the. A magazine asks its readers to call in their opinion regarding the amount of advertising in the presentation. Ask its readers to call in. It's obvious, isn't it? Nobody wants to say anything.
Convenient?
Yep, that's it. The magazine asks them to call in, so it's convenient. You got the time, give me a call. In a survey, 1,465 internet users chose to respond to the question posted on a newspaper's electronic edition. Is news online as satisfying as print and TV news? 52% of the respondents said yes. This is an observational study because the researchers, did they attempt to modify? No. All they did was ask them a question. Okay, what's the major problem with the study? Well, it is large. See, blinding. When you see that, just kind of ignore it. It's a convenient sample with voluntary response, which has a high chance of leading to bias. I think D is true also, but C is more true. You'd have a hard time convincing somebody that it only applies to internet users. That's more of a philosophical thing. But it is true that it's a convenient sample. Okay, 24. A medical researcher tested for a difference in systolic blood pressure levels between male and female students who are 12 years of age. She randomly selected 4 males and 4 females for her study. This is an...
I think she's taking blood pressure, no? Or is that observation?
She's just measuring blood pressure.
Is that observation?
Observation. She's not really giving them not adding to change the blood pressure. She's just, because the researcher does not attempt to modify. All she's doing is measuring. I know. Got all that jargon in there, and it sounds like it should be. What's the major problem with the study? What jumps out at you? It's not a convenience sample.
No.
See, blinding, you can lose.
Yeah. Well, and C is true. Like
8 people.
Yeah.
It's just way too small.
No. Yeah.
What can you say? How can you address a larger population from such a small sample? It's pretty hard to do. Remember, a large sample is 30 or more. That's typically the break off. Because we're going to see what happens. This empirical rule applies to continuous normal distributions. And the larger the sample, you don't have to rely on the fact that it's underlying normal because it's a large sample. It becomes normal just by being a large sample. So a lot of the rules that we look for are overcome just by using more and more people to measure or count. A sociologist has created a brief survey to be given to 2,000 adults randomly selected from the U.S. population. So it's random. Here are her first two questions. Have you ever been the victim of a felony crime? And two, have you ever been convicted of a felony? Is it an experiment or observation?
That's an observation.
Right. Because she's not trying to modify it. She's just seeking information. Now, what's the problem with this one? Which one of those makes the most sense? So you could D right away. As soon as I see blinding, I ignore it. They're not voluntary, so it has to be either B or C. And C doesn't make any sense, so focus on B. Individuals convicted of a felony are more likely to not answer the second question honestly. This goes to what we call validity. People don't want to know. It's like most people don't want you to know what their income is, right? It's the most hidden thing that we do. We don't. You would think the people make a lot of money would be happy to expose it, but no, they're not. They don't want to. And the people that are poor don't know either. So it's something we hide. So we don't answer that honestly. So certainly, if anybody was convicted of a felony, they would not want anybody else to really know about it. Now there are ways around this. There are statistical ways of doing this, and the person has to understand that you don't know which question they're answering. So there's a thing called this. It's called let's see, what's it called? Random response theory. Random response theory. What I do is I have two different questions. Let's say I want to know how many people in this high school smoked marijuana in the last 3 months, 2 months, whatever. If I ask them, guess what? Most of them are just not going to, because they don't trust me. But if I have a second question, did you eat breakfast this morning? And I show them the two cards. I say, here's the two questions. And I say, I mix them all up. Now, the thing of it is I don't tell them that I have, it works best at about 30, I have 30% of one and 70% of the other. And I mix them up. And I say, pick a card. And just answer yes or no. That's all they got to do. I don't know what card they picked. So I don't know what question they're answering. Right? And what happens is by reverse calculation, which I'm not going to show you because it's a little complicated, I can get a reading on how many actually smoke marijuana. I can get a pretty good estimate. It won't be perfect, but with the confidence interval, I can get it to within, a reasonable percentage. And I can tell you it's between, if it was actually 30%, I would say it's between 25 and 35%. And I'm 95% sure that the actual percentage is in there. So pretty cool, but you can do that. But you have to be face to face because you can't do that on a computer because they wouldn't trust you on a computer either. Oh, they can see what I really answer. You know what I mean? So it was one of the coolest things I studied when I was in college. It's called the random response theory. It really works, but it has to be done face to face. All right, number 37. Yeah, we're going to define a simple random sample because I think that's important. Okay, so there's a random sample and a simple random sample, and they're distinctly different. Random, you think they're related, but these are random samples, but they're not, strictly speaking, simple random samples because there's something involved, systematic random sample, stratified. So refer to the definition of a simple random sample. So we're going to do that. We're going to go back and find it. Let's see if we can find it here. Yeah. A simple random sample of n objects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. A simple random sample is often called a random sample, but strictly speaking, a random sample has the weaker requirement that all members of the population have the same chance of being selected. That distinction is not so important in this text. See the difference? All of these have everybody as an equal chance, but not every sample size has an equal chance. Not every sample of the same size has an equal chance because of the nature of how it's set up. Because this one, it all depends on where I start and how many I choose. With this one, I'd only have 10 different random samples. If everybody was given a number 1 through 500 for all of them. If everybody in here had a numbers from 1 to 500, I'd only have 10 different systematic random samples. So every student is equally likely to be chosen, but not every sample of size 50 is equally likely to be chosen. See the difference? All right, so that's what we call a simple random sample. So a statistics class with 36 students is arranged so that there are 6 rows. Can I erase this? There's 6 rows with 6 people. Okay, so you got 6 rows or 6 columns, whatever you want to call them. There's 6 rows with 6 students in each row, and the rows are numbered 1 through 6. We'll call these rows. I mean, that's what we call them in school, right down the road. It's actually a column, but we call them rows. A die is rolled, and a sample consists of all the students in the row corresponding to the outcome of the die. So those are clusters. You've got 6 clusters, and you roll a die, and if I roll 3, then this cluster is selected. And I get everybody in that cluster. So it's technically a cluster. So this sample is not a simple random sample, but it is a random sample. Okay, you see it? Okay. In B, for the same class described in Part A, the 36 students' names are written on 36 individual cards. The cards are shuffled and 6 names are drawn from the top. So you got all 36 students each one has a number 1 through 36. 1, 2, 3, 4, whatever. 1, 2, 3, 4, 5, 6, whatever. But they're numbered 1 through 36. However you want to do it. So the cards are shuffled, 6 names are drawn. So this is a simple random sample. Because each group of 6 is equally likely to be chosen as any other group of 6. And it is a random sample. Because remember, a simple random sample is always a random sample. But a random sample is not always a simple random. It doesn't go both ways. And C, for the same class described in Part A, the 6 youngest students are selected. It's not a random sample, and it's not a simple. It's not a simple. It's neither. It's purposeful.
Right.
It's a convenience. You're just picking the 6 youngest. So it's neither one. Okay? So, and little review here. Which sampling method divides the population up into sections, randomly selects some of those sections, then chooses all the members in that section to study? Which one was it? Yep, cluster. Who disagrees? Nobody takes a chance. The group leader has spoken. Number 2. Which sampling method subdivides the population into categories sharing similar characteristics and then selects a sample from each subdivision? So they're purposely not using the names like clusters and strata. They're using subdivisions. Which one is it? No, because they're selecting a random sample from each subdivision. In a cluster, you would take everybody in the subdivision. The subdivisions would be randomly sampled. Systematic means every nth one stratified. That's right. The polls, the political polls that they always have, those are stratified. They stratify them by age, gender, political affiliation. They stratify them, and then they go randomly select from each of the strata. The problem is they don't take the same number from each strata. They decide, oh, we want more of these. Who knows? The other thing is, when I was studying sampling methods in graduate school, to accurately, well, not accurately, but to have a plus or minus 3% differential, you have to sample around 16 to 1700, randomly sample that many people in the United States, which they don't do. They're only sampling up 1,000. And the other thing about the political polls is they always talk about the plus or minus 3% or 4%. That has nothing to do with the validity, like the truth. What it has to do with is the reliability of the sample itself, how it was taken. All they're telling you is that if we did this over and over, we think that the results would be within this reliability interval. We wouldn't necessarily get the same results, but we would reliably. We're saying that our technique is reliable, not the outcomes. Yeah, because validity and reliability are two different things. That's the notion of that random response. You want validity. You want to be as valid as you can. There's no validity to a poll. You know, technically speaking, when you do a phone sample, you just don't ask the person that answered the phone. You say, in your household, how many people live? And you have the person has a card, and the person answers and says, 7. And the gentleman, whoever's running the poll says, can I speak to the third oldest female? Because it's got to be randomized inside the phone number you call. But nowadays, you don't have that situation where phones are for a whole family, a whole household. Everybody has their individual cell phone. And so the samples that they're getting are very, very, shall I say, tilted. They're not, and plus they're not large enough. When you sample 1,000 people, it's like you're cutting your reliability and who knows what's happening with the validity. We don't even know how to measure the validity, but your reliability goes down. That plus or minus 5% is like almost like flip a coin, you know. So it's really dangerous. Anyway, I think I lost my. Where was I? RA1, where was, oh, here it is. Yeah, we said stratified. And then the last one. Blank is used when subjects are assigned to different groups through a process of random selection. The answer's in there.
Yeah, random.
Randomization. It's an arguable thing too. A lot of people don't think you can be totally random in any way of any way of reckoning. But we do our best. We do the best we can. I thought of the word that I couldn't think of before. It's called relative frequency. The relative frequency is the number of successes divided by the number of observations. Relative frequency. We're going to talk about probability before we're done, so that term will come up a lot. Let's see, before we leave, let's see if there's anything. Discrete and continuous on the back. So we know what discrete and continuous, the difference is, right? Discrete, you count. Continuous, you measure. A fish weighs 3.8 pounds. You count pounds or do you measure pounds? So it's continuous. A class has 14 students. Discrete. A coat costs $43.95. Discrete, because we count money. And a radar gun indicates a speed of 59.55 miles per hour. Measure so it's continuous. There you go. All right, so that's it for homework number 1. Let me make sure of something here. Next time, we are going to do data distribution. We'll talk about data and frequencies, relative or otherwise. Okay, any questions? Point of review, homework number 1 for 100% due Wednesday, midnight. If you don't finish a couple of problems, you can still finish them by Saturday, but you lose. If it's worth 5 points and you get it right, then it's 4.5. You lose 10%. So if you don't do anything until Saturday and you get everything correct, the highest score you can get is 90. So I try to bulk you up. I want everybody to get scores in the 90s for the homeworks, because the test, you don't get a second chance on the problems. You get a second chance on the whole test, but not on the individual problems. So by next Monday, we'll be done with Unit 1. So it's a slow process. So take your time and see if you can get 100 on homework number 1. Thanks for coming.
I hope everybody has a great
Yeah, have a
July.
great holiday. Don't
See you Wednesday.
get burnt.
Yes, right.
Be careful out there.
Have a good one, guys.
Any questions?
No, thank you.
Okay. Did you get logged into Pearson?
Yes, I did that all right now.
Let me see. Let me double check.
Okay.
1 second. Yep, you're in.
Perfect.
All right, so and do that pre-test. Don't study for it. Just get it done.
All right, thank you.
Okay.
Have a great day.
Likewise. Thanks.